Okay, uh, hey everyone, thank you for joining today's adventure into Java. Regardless of whether you're a seasoned coder or a curious beginner, you're in the right place. Today we'll dive into the vibrant world of Java, exploring its syntax, structures, and unique characteristics. Questions are not just allowed, but encouraged, so don't hesitate to jump in. And also, my name is Logan Emara. I'm the president of the Computer Science Club here. If you just want to know more info about our activities and more info about the club, just meet me after the presentation. And actually, before we get into Java, let's just go over the C++ workflow because I know some of you are already familiar from the courses here. How do you run a C++ program? First, you install the C++ compiler. For example, in our lab machines, we use the G++ compilers. Then you write your source code, compile your source code to local machine code, then you run your executable. I'm actually going to show you a short demo of. So over here, also just note this is not how big my fonts usually are. I made it bigger so it'll be more visible. I don't know if you guys can see anything, if it's visible, but so yeah, this is a basic C++ hello world file. You include your IOStream library, and our main method is our entry point into the program. All we're doing here is printing hello world, and we can just run that and see what happens. Yeah, self-explanatory, nothing too fancy there, but there's actually some stuff going on inside we don't usually think about. So what that's doing is taking that source code and compiling it to our local machine code. That means only my platform or type of platform understands the machine code for this. If I try to compile the same source file in a different architecture, for example, over here, and try running that. So I just recompiled the same source code using a different target architecture. We're going to get an error if we try running that. Bad CPU type and executable. This is actually a problem that's been with C++ development for a while. Before languages like Java and other intermediate languages, you'd had to write your source, recompile your source code for every different architecture you want your program to run. Okay, let's go back to the presentation. Okay. So problems with this approach. The executable can only be run on the target platform. If you want to distribute your C++ program to other platforms, you may need to make platform-specific adjustments and recompile your code for each target architecture. If you don't plan on doing the above, you just have to share your source code. So in a situation where you have some security or something you just want to keep secret, you don't want to try open development, that's a potential problem you can run into with C++ development. And here's a diagram of similar to what I just tried to show. I actually intended to run it on my Linux VM, the executable, but unfortunately it's not working right now, so I just had to use a cross compiler. But basically, the same source file could be compiled to different executables on different platforms. Even though the source file, like there's nothing different about it, it just ends up going to different executables for each platform. And I chose to use the same processor here to just show something that even I still kind of trip on sometimes. Usually when I say different platform or different architecture, we just think of the processor alone. But even the operating system has a part to play in how your machine code is created. And I know Linux isn't actually an operating system, just a kernel, I'll just put it there for simplicity. So things like system calls and all of that can be handled by the operating system. And if you have a different operating system and still have the same processor, you can still end up with different executables. And for those who might not know, executables just mean machine code, but the machine directly understands direct instructions for your computer. Let's go over some proposed solutions. We can utilize standard C++ libraries and employ preprocessor directives for platform diversification. So that's a lot of big words. Preprocessor directives, what that basically means is checking what platform you're currently on and executing some logic by that. So if I'm on the Windows, do this. If I'm on something else, do this. That's pretty much what it means. Leverage cross-platform libraries. So instead of making specific library calls, you could have a layer of abstraction and just using those libraries, and they'll be worried about the implementation for the different platforms. Cross-compiling, which is what I did in the example. Utilize containerization like Docker to bundle the application with your dependencies. I've personally never used Docker, but I know it helps a lot for situations where you run something on your local machine and you try to distribute it to other people and you can't seem to run it. It fixes that, so like it's not like you avoid the problem of, oh, it works on my machine. Everyone can have the same Docker image and run the same application with the same dependencies. Also, there's source code distribution, which I already mentioned, and intermediate language, which is what Java is, which we will be getting into. Java. Java is a high-level, class-based, object-oriented programming language that is designed to have as few implementation dependencies as possible. It is a general-purpose programming language intended to let programmers write once, run anywhere. The syntax of Java is similar to C and C++, but has fewer low-level facilities than either of them. Compiled Java bytecode can run on all platforms that support Java without the need to recompile. So in the example I showed, the C++ code was tailored to, when you compile the C++ code, it was tailored to your specific machine. It creates the machine code. But with Java, we have another layer of abstraction. So your Java code is compiled to some intermediate form that can run on any different type of platform. Java was developed by James Gosling and his team at Sun Microsystems in the early 1990s. Let me just go into some of the stuff I mentioned about Java to give more info. Platform independence. Java was designed to allow developers to write a program once and run it everywhere, meaning that Java applications are platform independent at both the source and binary level. So what we've talked about so far about having different executables for C++ is not a thing with Java. Safe memory management, automatic garbage collection, and the absence of pointers in Java reduce the risk of memory leaks and other issues related to memory management. I'm not sure how many of you have used pointers in C++ before, but they pretty much just point to a specific location in memory. And it's a lot of power to the developer to do that, but also comes with a lot of risk because you have to delete those pointers and know what they're doing, unless you can end up with memory leaks and things you don't want in your application. Java does all of that automatically. And also exception handling. You have checked and unchecked exceptions to hierarchical exception system. Java's exception handling model was designed to help manage runtime errors, enabling the creation of robust programs. Pretty much summarizing that, just Java has a more robust exception handling system than C++. And here's an overview of the Java Development Kit. It's the toolkit that allows developers to create Java applications. So if you want to develop Java, you have to develop JDK. It comes with the JRE, which is a runtime environment, and some developer tools like the Java compiler, the Java disassembler, the Java debugger, and Java documentation. I've personally never used the Java disassembler, but the Java compiler, we're going to use it obviously. And the Java debugger, I'm not using that directly, but with IDEs like IntelliJ, they do all of that for you and provide a nice interface, so you don't have to do it from the command line. The JRE has the JVM, some class libraries and other libraries. That's a lot of like J's and Java this, Java that. So just breaking that down a little bit. So contents of the Java Development Kit. The JRE, Java Runtime Environment. This is the executor. It enables running Java applications on your device. And we have developer tools. These are a set of utilities for developing, debugging, and managing Java applications. That's Java C, Java compiler. It compiles your source code into bytecode. Bytecode is the intermediate view of your code. Instead of just from source code to machine code, there's like a step in between, that's bytecode. Then JDB, Java Debugger, finds and fixes problematic code bits in Java applications. Like I said, if you have an IDE like IntelliJ, it uses JDB under the hood if you know it or not. So again, just a view of that, putting it all into context. Now going into the JRE, which is this green bubble over here, you have the Java virtual machine and class libraries. what do those mean? Java Virtual Machine. This is the core of the JRE. It executes Java bytecode and translates it into actions in the host machine's instruction set. So the first step was using the Java compiler to take your source code to bytecode. Then the JVM inside the JRE takes that bytecode and converts it to the machine code. So at the end of the day, we still need machine code because that's all computers understand. So that's what the JVM is taking care of. The Java API, which is all these libraries here, those two circles inside the green bubble. Just like you have your IOStream libraries in C++, just standard libraries that help the development process instead of repeating the same thing. Common classes you might need, like input, output, networking, mathematics, so on. And actually, before I go on, are there any questions about JDK, JRE, JVM? Okay. Just let me know if I'm going too fast or if I need to repeat something, because I know learning it as well for me, there's a lot of, because they all like JVM, JRE, JDK, those are like very different terms, but they all have their roles to play. So, yeah. And if you want to install the JDK, there's instructions on the PowerPoint. I put the PowerPoint on the chat on Discord. There's some installation guides as well. Go to oracle.com. It'll ask you for like your different architectures and stuff. So this is Linux, Mac OS, Windows. You just go in there and download for any platform you're currently using. I'm not actually going to go too deep into that. We're just going to use an online compiler today if you guys don't already have Java installed on your machine. There are like many online compilers out there, so just choosing any one of your convenience. This is an example. Okay. I don't know if any of you want to follow along with the coding examples. We're going to be having some later on. But, yeah. If you need time to get the URL, just let me know. I can keep it on for a few more seconds. When you're at the website, you should be good. You don't have to copy like the code. We're gonna do that ourselves for our examples. So if you're on the website, I think everybody is on there. Okay. So let's talk about Java, the structure of a Java program. I'm gonna show you an example later on. Oops, sorry. My eyes are terrible today. I don't know what's going on. We have classes. These are the blueprints for objects. Each Java file contains at least one primary public class. This is different from C++, where you don't have to have a class for your main method. In Java, everything you do has to be encapsulated in a class, which is just a representation of what you're making. Methods block of code that perform specific tasks, like the main method, which is the entry point of Java applications. So this is what the class looks like. This is what the main method looks like. This is the entry point of your Java program. Each application you write has to have at least one main method. That's how the program knows where to start from, just like your int main method in C++. So classes, methods, variables, name, memory, locations are stored data having a defined data type like int, string. We also have statements. These are single lines of code ending with a semicolon that perform actions such as assignment or method calls. Comments, just like C++ as well, non-executable lines that provide information about the code, starting with the double slash or slash and wrapped in slash and asterisks for multi-line comments. Breaking this down, we're actually going to write this code, but just to give some information before we start coding. Your file name has to be the same name as the class. So in this example, we have exercise 1, or just ex1. That's the name of our class. When you're compiling locally with the Java development kit, your class name and your file name has to be the same or you get a compilation error. It's not going to work. And this is our main method, public static void main. That's like a lot of words on that line. What it pretty much means, static means it belongs to the class. For those who've taken object-oriented programming or something similar, you know, that just means you don't have to create an object of your class. You call it main method. Void means it's not returning anything. Usually with methods, you can have a return value. It just means we don't have to have a return value. And string args, that's the argument you can pass to the program when you run it on the command line. You don't actually have to pass anything. It's actually optional. And system.out.print line, this is just saying print this to the console. Print this message in one line and go to the next line. That's what the ln stands for, print line. The system class in Java, found in the java.lang package, contains several useful class fields and methods, which are largely used for interacting with the system, the computer. It contains an input stream, in, and also an output stream, out. A print stream, which is connected to the console output. This is what we use. The OUT stream is the output stream, and that has methods like print line we can use to print to the console output. And running a Java program. So we're just going to take a short break here and actually we're going to create a simple hello world program similar to what we have here, but just in Java. I have the JDK installed here, so I'm just going to make a new class. If you're working on the website, so this, you can follow along as well, but I'm going to call it this line here, package Java workshop, is just means it's under this folder. You don't have to worry about that if you're using the online compiler, since you're not going to be working under any specific package. So we've created the basic skeleton of a Java program. You have your class declaration here, and it matches the name of the file. File names in Java always end with .java. So hello world, and you have our entry point here. All we want to do is just print hello world to the user. So we're going to do this. And that's our program. You can try to run it here and see what we get. Hello world. And if I try running that on the website as well, we should get the same thing. Also, I should probably have noted, but here the name of the file they're using is called main.java. So every class you write has to have the same name, like I mentioned. You can have a different name. You can actually try change this to something else and see what happens. So just like how it was before. Sorry, the Grammarly's. Okay, let's run that, see what happens. Well, it's working, but that should not work. We could try to do it on our local. See what happens over here. Change it to something else. Yeah, you're supposed to get an error when you try to do that. I'm guessing because it's on mine, didn't really check it as strongly as it would if you run it locally, but that's besides the case. Okay. So we can get back to the presentation. So running a Java program, my compiler and doing it locally. These are the actual commands you write into your terminal. Java C, which just tells compile my source code into bytecode. Java C and the name of your Java file. And to run your program, you run Java and the name of your bytecode. Just to circle back to the image to get a better understanding of what's going on. So Java C is the Java compiler. It takes your source code into the bytecode. So when you run Java C in the name of your file, this part is actually what's responsible for creating that bytecode. Then you run Java, and this part takes over. It takes that bytecode, translates to machine code. All right. So I think now we can do one of the exercises on for those who haven't seen it. If you're not familiar with Caddis, you just go to the website over there. Caddis.com, you can go to contests. Just start from the top. Caddis.com. Then there's this tab over here called contests. Just click on that. Then there should be a Java workshop. Just search for it. Command F on Mac. I don't know what the shortcut is on other platforms, but that's the program we're going to be running. I'm going to go through some of the problems here. Okay, hello world, which is what we just did. You can just copy paste what you already have from the previous submission. See if it passes their test over there. And always keep in mind the name of the file. So here's another example here. It's called hello.java. So I have to call my class hello. Otherwise, I'm going to get a compilation error. And this, they want you to put hello world with an exclamation mark at the end instead of the regular hello world. And when you're done with that, you can just submit. Let's see what this is. Okay, accepted. Only one test case. Makes sense. Also, if anyone has any problems getting into Caddis, let me know. I can just come check in and see if I could get you logged in. Okay, back to the presentation. Data types and variables. Java has two categories of data types. You have primitive data types, so simple values like int, float, char, boolean. Pretty much most of the simple data types you have in C++ are represented in Java as well. You also have reference types, objects and arrays, so string, array, object. And also you define reference types, like if you define your own classes, that also falls under reference type. Variables. A variable is a placeholder for storing data. So storing data values. Declared with a data type followed by the variable name. So we have the data type, variable name, and a value. I can show you what that looks like in a second. Data types and variables. We have no pointers in Java, like I mentioned. Java does not use pointers. References to objects are handled automatically. Ensure security and simplicity by avoiding diagram manipulation. A short note on that, if you watch a lot of interviews with James Gosling, who was the creator of Java, he mentions that specifically was also a main motivator when creating the language, because at the time, a lot of the security concerns in industry programming was with buffer overflow errors in C++, and that pretty much means a malicious actor could come in and overwrite your memory into somewhere it's not supposed to and do funky stuff, which you do not want. Java pretty much solves that problem. Also, automatic garbage collection. Java automatically removes unreferenced objects, managing memory efficiently. Developers need not explicitly free memory, minimizing memory leaks and enhancing stability. In C++, we have this thing called like stack and heap dynamic memory. Stack memory is pretty much what is, you don't have to control what goes on there. With heap memory, you have to create using the new keyword and deleting. In Java, you don't have to do any of that. If none of that made sense to you as well, you don't have to worry about it. It's something you do, especially if you go into 1620 and 2620 here. Should talk about some of that. Okay, I can do a second exercise. So exercise B is called, I'm not going to try to pronounce that, but the question is asking, Anna and Hans are packing cars for party guests. When all party guests are seated and all cars have been parked, they discuss how many cars they've parked. Anar tells Hans how many cars he parked, and Hans tells Anar how many cars he parked. Now they want to know how many cars they parked in total and ask for your help. The input is on 2 lines. The first line contains a single integer, n, the number of cars Anar parked. The second line contains a single integer, n, the number of cars Hans parked. Print a single integer, the total number of cars Anar and Hans parked. So pretty much all this is saying is we're going to have 2 inputs, 2 lines. The first line is going to have the amount of cars Anar parked, and the second line will have the amount Hans parked. What we need to do is just output the sum. I'm going to show you right here what that looks like. The operators we use for that. So first declare a class. So again, I'm just creating my basic Java skeleton. In C++, we have the IOStream library. This handles inputs and output. In Java, we have a scanner class for getting our input. This is how we include it. So what I pretty much did there is importing the scanner class into my project, and I'm declaring the scanner type of inputs. Scanner inputs equals to new scanner system. New scanner is the keyword I use to create a new object of a class, in this case scanner. And what that does is just pretty much take inputs from the user, the console in this case. System in, if you remember from the slides, is part of the input stream in Java. But yeah, you can go through back and look at that. It's a part of the input stream, and we use that to just take input from the user. So that's scanner. So what we need to do is read 2 lines of inputs, number 4 and number 3, and print their sum. We first declare 2 integers to store the values we're going to hold, int x, int y. Then we get. Sorry? Oh yeah, you can try that. So, no, he actually made a good suggestion. I think in C++ and other languages, you can, instead of doing like the same declaration in multiple lines, if they're of the same type, you just declare the type once and have comma-separated values for the variables. So int x, int y representing the amount of cars for Anar and Hans. And to get that, we just do this. Puts dots next int. I'll talk about these methods in a second and what it means. So what we're saying here is x is going to be the first input you see. Input's the next int, that's the scanner. It goes through inputs line here, it takes the first integer, which is 4. And stores that for x, and y just is going to pick that up. You also have other inputs methods like inputs.nextLine If you do that, this will be a compile error because unlike input, the next line takes the whole line here and treats it as a string. So if you want to get the integer number, you have to do some typecasting or something else you may or may not go into today. But just a heads up. So I revert it back how it was. The question wants us to get their sum, so we just add it like you would in any other language. And when you have that sum, you want to display it back. And the test cases, they shown 4 and 3 were the amount of cars they parked, and 7 was the output, which makes sense, 4 plus 3. Same here. So to display that output, we do this. The print line method again. You can try running that. Also, for good practice, when you're doing competitive programming, you probably don't want to run it on the website first. You try running it on your IDE or any online compiler you have to see if it actually runs, if you have any errors like type errors or just city errors. Let's see what it says. Okay, let's copy the same input and see if we get the same output. Oh, well, there's the first issue. Something's wrong. So let's see what happened here. X and Y. This is also, it should work, so we're just going to debug and see what's going on with our program. Okay. And if any of you have any suggestions as well as to what might be going on, please feel free to chime in. Okay. Okay, it actually is working. I don't know why it didn't show up on the online compiler. Just look there again. Yeah, I'm not sure why that's not showing up on here, but yes, the code is working locally. We can try going to the next example. Okay. So we've covered data types and variables, automatic garbage collection as well. Okay, operator fundamentals. We've already used one of them, which is the plus operator. There are other ones like minus, multiply, divide, and that one just takes the remainder. This one right here. There are other operators like relational operators, usually return a Boolean value. So the first one is equals to. So if 5 is equals to this, it's going to be equal to true. No equals to, less than, greater than, less than equals to, greater than, true. You also have logical operators like and, or not. And assignment operators usually used with variables equals to the variable plus the other constant, and all these other ones. We're not going to be using any of these ones today, but if you want to. They're just a shorthand way of doing things. Control flow statements. This checks if it checks a condition and executes the block of code if it's true. So the syntax for that is if condition do this. So if your condition value is true, I want to execute that piece of code. For, this is a iterative statement, so it's a loop through a block of code a defined number of times. Syntax for initialization, condition, update code. I'm actually going to be showing you an example of each of these in a second. While loop, similar to the for loop, but it doesn't have a defined number of times. It just, the code executes as long as the condition is true. Any questions on control flow statements? Okay, let's see what these actually look like in code. Okay, let's call this control statements. Again, creating a skeleton. You know, it's like this is boilerplate. We're always going to do it anytime we want to create a single application. And we want to show some control flow statements. Starting with if, this is what it would look like. If true, code here. So we're going to have an if statement. It evaluates the condition, a Boolean condition which is wrapped around this brackets over here. If the condition is set to true, then it executes the code. Let's see what that actually looks like with a real example. Declare an integer x equals to 7. I'm going to check if x equals to 7, print something, right? So system.out.print line, true, else false. And we can try to run that and see what happens. Before I run it, does anyone have to make a guess on what's going to happen when I run it? Sure? Yeah. Yeah, nothing, no tricks there. True. If it was false, that would have been very fun. So that's an if statement. You can also have else if statements. Something like if, else if, x equals to 6, do something else. Say it prints x is 6, else false. This doesn't make much sense, but just for I'm just gonna leave it that way. But if x equals to 7, print true. If else if x equals 6, print x is equals to 6. Else just print false. Same thing, we're gonna get true again. And try changing x to 6 to see what happens. X is 6. So those are the general if, else statements. When you chain these together, you can have a logical flow in your application. There are many instances where you're able to use it almost every single time you're writing an application. So let's go to for statements. For I equals to 0, if I is less than 100, I plus plus code to execute. So we have the for statement is, this is the same as the for statement. We have a declaration here. Here we're defining some integer I and equating it to 0. And we're going to have a condition here that checks if I is less than 100. If it's true, we do this I plus plus, which means I is equal to I plus 1. So we're going to increase I by 1. So that's a good way to do something a specific amount of times let's say we want to print my name 100 times, we're going to do something 100 times. That's what we're just going to do over there. So let's print something. Let's print I actually. What's going to happen? Does anyone want to guess when I run this? Yeah. 0 to, and what's the upper bound? What's the 99? Yeah. Yep. So that's correct. I'm going to start all the way from 0 to 99. And the reason why I use I, most of you probably already know, is just standard practice. I don't know. I don't think there's a specific reason. It's just something people do.
It should stand for iteration, right? Iterating.
That's a good point. Maybe, yeah, probably actually. That makes a lot of sense. Iterations. Okay. And we also have while loops. So for those of you who are C++ programmers, you probably realize by now it's not too different. When you get away from the basic boilerplate, the way you write code and logic is still pretty much the same. Less than 0. Do this. Print X. And then you want to make a guess into what this is going to do. Okay. Trick question. Also this. Okay. What if I exactly. So I feel like this is going a bit slow. We're going to go into more advanced stuff soon, but just the foundations for anyone who might not be familiar. Let's run that and see what actually happens. So yeah, like he said, 56 all the way down to the last number. And those are control statements. Now we can go through some other exercises actually before we move on. So exercise C, D, E, and F. Just practicing with some of the stuff you just learned about control structures and operators. You can solve these on your own, like any order you want, but I'm just going to go through from C to F. So what this is asking for C, just to break down the question, we're going to get an input, and if it's a multiple of 2, we're going to print out ball, unless we're going to print Alice. So 1 is going to multiple of 2, so we're going to print Alice. But 2 is multiple of 2, we're going to print ball. I can just keep on doing that for every integer input they give you. So this is a simple program. If I were to ask you how you would implement this, does anyone have any suggestions? Module operator? Yeah. Okay, let's do that. Again, you have to make sure the class name is the same as the file. Good. When you write that method for a couple of times, it just sticks. So we want to read the inputs. We're going to have one line of inputs with just a number. So let's declare scanner inputs equals to new scanner system.in. Before we can actually use the scanner, we have to import the class. So we do that here. So we have a scanner inputs. Now let's read the number. Let's call it x, integer x. x equals to inputs dot next line. That's our number. And like he said, we can use the modulo operator to check if it is a multiple of 2 or not. So we can do this here using, what control statement can we use? Does anyone have any suggestions? You have like if, else. Yep. If x modulo 2. So that's the modulo operator. It looks like a percentage. Yeah. Modulo 2 equals to 0. So we're checking if the remainder when you divide it by 2 is equals to 0. If that's true, it means x is indeed a multiple of 2. We're going to print bulb. So system.out.print line bulb. Else, if it's not true, then it's not a multiple of 2. We're going to print Alice. Alice. Before I run, does anyone see any possible errors here?
I have what's the question, Nancy?
Sure. Sure.
Is it like C++ where you can omit the curly braces if your if is like one line?
You can try that actually. I'm not sure.
Yeah.
Oh, the ternary operator? Yeah. If it's
no, not with the operator.
Okay.
You can just like one line it. If it's one line, C++ will just
all right,
take it and go to the next line.
you can try that.
So it's not there. But also input.next line takes in a string, so we have to cast it back. Or cast next line into it.
Good point. So previously I did the next int instead of next line. And like I said, I forgot my own instruction. Next line takes a whole line of inputs as a string instead of an integer. And actually, since he called, I'm just going to show you how you would parse it back. You don't have to do any of this. It's just for to show you. There's an integer wrapper class, which is just a wrapper class around the regular primitive int type. And it does all the same things an integer can do, it just has more methods. So in that class, it can parse an integer out of a string. And that's what he mentioned. But we're not going to be doing that. We're just going to read the regular integer. X equals to input the next int. And to go with good practice, let's try running this locally first. See what happens. Okay. Yes, we did an import scanner here, so let's just do that. Okay. Just run and see what happens. Get rid of input. Alice, we can try again with something else. Multiple of 2, let's use like 8. Bulb. Okay. So to answer your initial question as well about not having the curly braces, yes, if you have only one statement, you can just omit those. But for readability, I usually just prefer to do this so it's very clear what I'm doing. It's just like visually wrapping the logic into a block. But it's perfectly fine to do this as well.
Question marks, there's 2 question marks. Okay. What option do you have?
Have any of you heard of the ternary operator? Except for yeah. So we're actually not going to cover that, but that's something to look into. Instead of having 1, 2, 3, 4 lines of code for this, you can just do all of that in one line. That's the advantage. So let's try running this. I don't think I see any more errors here. Okay. Okay, looking good. It's gonna go through a lot of test cases. This is a world. I don't know why it's so many test cases, but if you're familiar with competitive programming at all, you know like it's very frustrating when you have like, for example, this is like I have all these test cases passed like the last 4 years, right? That's like the most annoying thing. It's so freaking annoying. But for those of you who want to like do competitive programming stuff, we also have information on our Discord channel. If that's something you want to get into. But yeah, let's just see. Hopefully that doesn't happen yet.
Yeah, I wonder if Caddis could do some kind of, just get some kind of statistics of which fails are to occur and maybe try to test that first. So it saves testing because it's even better for them to not use their own servers, right?
I don't think like if what part of a code fails, actually.
Because it's doing multiple tests, right?
Oh.
So imagine that they, as you said, like the 80th test, like 80% of the ways when people usually are going to fail there, they could put that test as the first one, so they failed already.
Yeah. You have some experience with Caddis? Like
no,
right?
I literally installed everything
Oh.
today when you guys showed up as well. I did yesterday. I did like the whole ones with those just to see how it goes. 'Cause,
Yeah. This one? Oh, my IDE? Oh yeah. You just read it. Okay, sorry. Just leave that up for a second. So it's like about I left about 4 questions going over operators and input-output stuff. I'm only going to solve 2 of them and move on. You can solve the rest when you're free. The contest is going to post in about 2 days. I can extend it if you guys want more time as well. I'll also try to make a GitHub repository as well for all the solutions. So if anyone wants to look at it later on, be accessible on there. I'll put it on the Discord channel as well. So that was question ABC. Okay. We're gonna do one more. This one is a little bit more complex, but not impossible. I'll just read over the question once so everyone's on the same page. In the United States of America, telephone numbers within an area code consist of 7 digits. The prefix number is the first 3 digits and the line number is the last 4 digits. Traditionally, the 555 prefix number has been used to provide directory information and assistance, as in the following examples shown over there. Telephone company switching hardware could detect the 555 prefix and route the call to a directory information operator. Nowadays, telephone switching is done digitally, and somewhere along the line, a computer decides where to route calls. For this problem, write a program that determines if a supplied 7-digit telephone number should be routed to the directory information operator. That is the prefix number is 555. So pretty much what this is asking, to summarize, because that's a lot of words, you're going to be given the inputs, how many integers, 1, 2, 3, 4, 5, 6, 7. You're going to check if the first 3 numbers are 555. That's what the question is asking. If that's the case, you print 1, also print 0. Before I go, does anyone have any proposed solutions for that? Or if I re-explain the question, so if it's still confusing?
Is it masking?
Sorry?
Masking to cut off the first 4 digits.
Masking? I don't think I'm familiar with
That's
this.
what it's like.
Yeah.
We just
Could
couldn't
do that actually. I think so.
I don't know if there's a better way, but like you just do model 1,000.
Oh, yeah? Yeah.
Model 1,000 or 10,000 to cut off the first
Sure.
4 digits.
Yeah.
Or last 4 digits.
Yeah, that's one way. So what you're saying is doing a modulo, then subtracting that from the original value? Is that what you're saying?
Well, if you do a module 1,000, you cut off the last 4 digits, right? For example, the first one, you cut off the 1212.
Okay. Let's look at this example. Let's see what happens if you do a modulo 1,000.
Or 10,000, I don't know. Now I will have to test.
10,000, so that's 1, 2, 3, 4. This is going to be the value returned 1212, and notes the first.
Oh, wait, no. You're comparing something else. That's off.
It's division is what.
Oh, it's, yeah.
Integer division will cut it off. But
Yeah.
does that work in Java?
That's a good question.
Because
In C++, when you divide an integer by another integer, you're always going to get an integer. You're going to get a double or any type of floating point number. What that actually does, if you don't know what you're doing, it could do something like this. 5 divided by 2 is 2.5. But if you declare a 5 variable in C++ and a 2 variable and try to divide it, you're going to get 2 instead of 2.5. And what we call that is flooring. It just takes the lowest integer instead of, even if it's 2.7, it's still going to be 2. That's a feature of a lot of programming languages, C++ type programming languages, including Java. And we can actually use that in this question. But what you were saying about modulo could also work. I imagine if you do like the amount of zeros to remove all that 1212, then you get 555,000. They just divide it by how many zeros again? It's more convoluted, but it's definitely going to work. The easy way is just to take advantage of what Luke mentioned. So we're going to do that right now. FYI. So we're going to read the inputs. So let's declare scanner. That's in. We also have to import that same scanner before we can use it. So like Luke said, we read the input. Int x equals to inputs dot next int. Then we just divide by how many zeros do we need? 1, 2, 3, 4. So we want to get rid of 4 zeros. So int final value. Also, you can call variables anything. I just use these. Goes to x divided by, should be 4 zeros. Just confirm again. 1, 2, 3, 4. So we're going to get the first 3 digits that way because it's going to run onto the slow integer. And that's not all. When we get that final value, which is going to be the first 3 digits, we want to check if it's equals to 555 or not. And depending on that, we're going to have different operations performed. So control statements come in again. If final value equals to, double equals to means equals to 555, print 1. Else 0. Let's run that somewhere else first. Let's see what happens. I'm gonna leave that here. Anyone's still writing? Okay, I forgot to put my semicolons. Let's copy some of their test cases. So this should be 0. Okay, seems to be working. Let's try one that's supposed to be 1. Oh, something went wrong because that's supposed to be a 1. Can anyone see something wrong with my approach?
Yeah.
What is the previous? Yeah, I bet. Thank you. think let's put that back into Arcadis. See what happens. First few times I tried to run, compile error. I was just about to say the first few times I ran, I got a compile error, so let's see why it's failing to compile this time. Oh. Okay. Okay. So yeah, this is my computer does this weird thing where if I do a full stop, like sometimes it does twice instead of once. So those like double full stop, they're supposed to be just one. So Java the utility scanner returns to access the scanner class that is located under utilities, which is under the Java API. So that's access it with the dot operator. And yeah, that's problem D. There's still problem E and F. These are also interesting problems, but given the time and how we're already over, I'm not going to go over these ones. Just let you go over that whenever you're free. Let's move on to the PowerPoint. We're almost at the end. Strings. Strings in Java are objects that represent sequences of characters. They are immutable, meaning once created, they cannot be changed. Here are some methods of the string class in Java. We have length. It returns the number of characters in the string. So length here is going to be equals to this string dot length, which should be equals to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it also counts the space in between as long as it's inside the quotation marks. And splits. It splits the string based on the provided delimiter and returns an array of substrings. That's all the big words.
So Java is not like C++ because it'll count everything at runtime, right?
For a string?
Yeah. Or is it like C++ where it'll have that end character at the end?
I'm not sure how different it is to C++ end character, but I think with Java it's like a backslash and a like an N or something. I don't know what it is for C++. Somebody could probably remind me, but that's how it is. When you're actually writing your own strings, you don't include end character.
Yeah, it's just added by the program itself.
Yeah, that's a good way to think about it. Yeah, and then with the examples we found on Caddis, it's not shown there, but sometimes they also include the end of line character or end of string character, whatever you want to call it. So what split does here is gonna split the string into an array. We're gonna talk about arrays in a second as well. It's gonna split the string into two arrays. This is the parameter passed the method. So it's gonna split the string up like this: hello to be one string, and world to be another string. So that's what split does. You can pass in regular expressions. That's what that's saying there. That's just one character. But you can have more complex representations to just cast a bigger net. We're not going to go over all of that right now. But yeah. We also have some problems for strings, problem G and H. Good problems. They also require some knowledge of arrays and array lists, which I'll go over in a second. This is problem E, F, G. So what this question is basically asking is, you're going to be giving an inputs. It can only be U. You're going to have U a certain amount of times. You want to find how many times you just press how many times U appears. So we've actually covered the method you need to do this. Does anyone want to say like how they'll solve it? Like which method they'll use? Keep in mind, U is always going to be U, so you're going to have like U, X, U, U, Y, something. It's always going to be U. So is there a method to find the length of a string?
The dot length.
Yeah. So that's literally all your prints. This question is just checking your understanding of methods provided by a programming language. I think C++ would have something similar as well you could do the same thing for. Or you could just loop through each individual character in the string and print that out. It's more convoluted. But that's how you would solve this problem. I'm not actually going to go over that, but you can do that on your free time. And greetings. This one is a little bit more complicated. So we're going to be giving, like, hey, it's going to be a different form of hey every time. What you have to do for the output is just to double the amounts of e's that show up. In this instance, you have one e in hey, and the output is going to be 2. So e, 1 times 2, 2 e's. Here, I don't know how many. 1, 2, 3, 4, 5. So you're going to have 10 e's there. Since we're dealing with just one character, it's a little bit more complicated. But just to ask, does anyone have any idea of how they would approach this problem?
Pull the H and the Y off.
How'd you do that? I mean, that's, yeah, you're right, but how'd you do it?
Use the split.
Good. What would you pass to split? So in this example, we passed like the comma. If you want to use,
Oh, you.
no, sorry.
I don't know if you want to. Well, I mean, you can just take length minus 2.
That's what I did. It's easier, but with what you're saying, it could work. You can make an array by, so just when you call split, you're actually creating an array. So if you pass in h, for example, you're gonna take out h and just create one array of ey. You also have to call split on y, which is, you're gonna run into some, it can work, but you're gonna have to massage stuff a little bit. With what he mentioned with the length, it's just a way of simplifying things. We're gonna send the length of the first one hey, which is gonna be 3, because there are 3 characters in there. And we're gonna subtract 2, because hey, we're gonna start with h and end with y. So you have, that's your number of e's in the first inputs, 1. Then you multiply that by 2, which would be the amount of haze you have in your final output. But that's just half of the question. The other half is displaying that new hey. I'm not going to speak much about it. I'll just let you think about that if you want to solve it on your own. Again, I'm going to put GitHub solutions for everything after this. So if you can't, you can look at that.
So is there because strings are immutable, right? So is there a string builder object?
There is.
Okay.
Yep. Actually, talking a little bit about immutability, let's just go to the IDE here. Does anyone want to know what's going to happen? He's actually correct, which is counterintuitive. When it says strings are immutable, it means,
Oh, right.
yeah. So that's actually something I used to get caught up in a lot. I still do from time to time. Because the way it sounds, you think it means, okay, strings are immutable, I can't change it, so why am I allowed to change the loop? You actually didn't change the string object here. So when you did this and wrapped it in quotation marks, you told the computer basically create this space of memory and put Maro inside it. The immutability means just that part is immutable. So I can't go into that specific block of memory and change Maro. If I want to do anything to S, I have to assign it to a new string object. So that's what that's doing. So it is immutable, very much immutable actually. You don't have stuff like append, for example. If it was immutable, you have like a method like append, which you can't append to a string because it's immutable. If you want to do something to a string, you have to create a new string equals to another new string. You can think of this as calling new string constructor. In Java, it's built in, so you don't have to do all of that, but that's what it's doing under the hood. And string builder. Strings are immutable, but string builders are immutable. Okay, string builder. Okay, I have to import that class. Okay, seems like I'm good. Builder. Let's append. So you can append a string to a string builder, which is different from a string. So if you're doing a new string, the string builder lets us change our string before actually get the string out of it. It's a little confusing to think about, but string builder is going to build your string. String just creates a string that's mutable. That's the best way to think about it. So builder.append, blah, blah, blah. But you can use this builder as a string. You have to convert it back to a string when you're done all your operations. Can do some string final equals to this. Equals to builder of string. Because this will let you still know a string is just a builder of a string. That's a builder probably string. It's useful in operations where you're having a lot of string operations back to back. So if you have like 100,000 people in a database and trying to process everyone's name, it's going to be very costly to like assign a string variable because every time you're creating a new string variable, string object in memory, and that's just very costly. Instead of doing that, you have think of this like one block of memory here, and you just append to that, and you just keep on adding and adding and adding. Otherwise, with this method, you could have like multiple objects of strings at the same time when probably only using one of them. That's a good way to think about it. I'll leave that for you like to study more if you want. There's a lot of resources online. But yeah, that's a good point. Thanks, Luke. So that's string and string builder. The last thing I'm going to talk about is arrays and array lists. So an arrays in Java are homogeneous data structures implemented in Java's objects that store fixed numbers of values of a single type in sequential memory locations. What a big word. What that basically means is arrays store data of the same type. So if you have an array of things, you have integer, you can have a string or a float or a character, only one type. And sequential memory locations mean if you have in the memory in your computer, each individual array is going to be stacked next to each other. That's what that means. You don't have to worry about all of that for now. It's just implementation detail. And this is how you declare an array. Ints, square brackets, my array equals to new ints. What that is doing is creating an array of 5 integers. It's going to have 5 spaces you can fill with any integers you want. So ints initializer is another way to do it. Instead of doing the first one, you can just use the angle brackets and put the members directly. And this is how you access and modify elements. Int first element equals to initialize array.0. That's going to take element 1, just this one. Initialize array 0 equals to 6. You're going to set the first element to 6. So it was first 1, now it's going to be 6. And you can also get the length of the array using the length attribute. Arrays provide a straightforward syntax and memory-efficient storage for multiple items of the same type. They offer easy iteration but are fixed in size once instantiated. So when you declare this array with 5 elements, or even this one, you can't expand that array anymore. It's like consent immutable as well. You only have that and you're stuck with that. If you need an array with 10 objects, you have to create a new array. But that's where array list comes in.
Can you specify the size of the array, like based on something at runtime? Do you know?
Yeah.
Like because in C++, say that like you can't bring in like the first int that tells you how much data you get, and then I try to put that into an array, but I can't do that.
Yeah.
It assigns the size of that compile time.
Let's try that. So what he's basically asking is, instead of declaring the size of the array in the code directly, we take some input from the user and use that to declare the size of the array. If that's legal in Java, you can try to run it and see what happens.
Yeah.
int array equals to x. So we're gonna have an array of 5 elements. That's all we need to do. If this count, we're gonna get a compile error, so that's all we need to do for this. See what happens. So yeah, we didn't get any compiler errors, so that's valid. Actually, no, wait, I'm over myself. I have to put the integer first. Yeah, so that's valid syntax for Java. Other way you could do it is just declare, comment this out. So now we have an array of 5 elements. That's our program. Okay, back to array lists. If you're familiar with C++, these are just Java version of vectors. So vectors are resizable in an array. An array list is a part of the Java collection framework and resides in the java.util package. It provides dynamic arrays in Java. To use an array list, declare it and then instantiate it using new. The new keyword. So array list and the arrow brackets. It takes in the type of the array list. A note in the type, it can't be a primitive type. Primitive types are ints, boolean, character, float, double, a few others. It has to be a reference type. In Java, we call those generics. They only take reference types, so like strings, objects, or any reference types you define on your own. That's just, if you want to do an array list of integers, you can't use the primitive version of an integer, you have to use the wrapper class, the big I. And you create a new array list. And to add elements, you use the add method, list.add. In the parentheses, you pass the method as the name of the elements, the element itself rather. Access elements, you use the get method. This gets the elements at index 0. So just the last code excerpt for this, we're going to create an array list. That was an array. Let's create an array list. What do you want to create an array of? Anybody have suggestions? Integers, floats, strings, anything?
Is there
Yeah, there's a double. Let's try using the primitive double first and see what happens. My list, so new array list, double. It's complaining. And why it's complaining? Because, like I said, it can't take a primitive type. In Java, there should be a wrapper class for double. Yes. So wrapper classes are just a way to go about way of putting a double in your array list, because it can only take reference types. But you can just pass in a regular double, and the compiler will treat it the same way. Let's try and add some floating point numbers to this and see if it works. My list.add double E. Any double? Anyone wants to give an example of a double? I'll just do 4.0. And let's print. There's only one element in this array list, so it prints the first part of it. My list dot get 0. Getting to 0. So it's 0 index. 0 means the first element of your array list. Let's see what happens. First of all, does anyone see any possible errors here? So go ahead. So that's just an example of a wrapper class double. There's also other ones like integer. Actually, before I get into that, just to know for array lists, you don't have to do this. You can just delete that. The compiler already knows the type. You can infer the type from the type declaration here. So you don't have to repeat yourself. Do integer. It's going to take type of integer. You can do other character. So there are these things called wrapper classes that take simple primitive types and adds features and classes around them to make them reference types. And yeah, that's pretty much all I had to show. There are other questions as well. If you go, the last question has, you can solve it with arrays, you can solve it without arrays. But I recommend going through this one as well. And yeah, I'll leave that to you guys. If you have any questions, you can let me know in the Discord and I can get to you on that specific point. But any confusion on arrays and array list, I kind of went over that pretty quickly. Yeah, that's it. Sorry I couldn't go further. We only have like a limited amount of time, and I went way over. But in the future, if you guys want something, you can go deeper into other parts of Java, except the basics. But yeah, that's it. Thank you for coming, guys.
Thank you.